In today's digital landscape, data reigns supreme. From social media interactions to financial transactions, we generate an overwhelming amount of data every second. This data, often unstructured and raw, holds immense potential for insights and innovation. Python, with its powerful libraries for working with JSON, CSV, and APIs, emerges as an indispensable tool for anyone looking to navigate the world of data. JSON enables seamless communication between applications, while CSV stores tabular data effectively. APIs empower us to access and leverage data from various sources. This essay will guide you through the essentials of working with JSON, CSV, and APIs in Python, equipping you with the knowledge and skills to confidently tackle real-world data challenges. In the interconnected world of web applications, a common language is essential for seamless communication. JSON provides a lightweight and human-readable format for representing structured data, making it ideal for data exchange, particularly in web APIs. Imagine JSON as a set of key-value pairs, similar to a dictionary in Python. This simple yet flexible structure allows for representing a wide range of information, from user profiles to complex financial data. JSON's standardized format allows different programming languages to parse and understand the data, fostering interoperability in the web development world. Its simplicity, flexibility, and widespread adoption make it an indispensable tool in the modern data landscape. Python, with its intuitive syntax and readability, has become a favorite among developers. Its powerful libraries provide a seamless experience for working with JSON data, making it an essential tool for modern programming. The built-in module offers a comprehensive set of tools to encode and decode JSON, enabling you to effortlessly integrate JSON manipulation into your Python projects. To decode a JSON string into a Python object, the function comes to the rescue. This function takes a JSON string as input and transforms it into a Python dictionary or list, depending on the structure of the JSON data. Conversely, to convert a Python object such as a dictionary or list into a JSON string, the function proves invaluable. This function takes the Python object as input and returns a JSON formatted string, ready for storage or transmission. For example, consider the following JSON data. JSON_data = name, Alice, age, 30, city, New York. To convert this JSON string into a Python dictionary, you would use the function Python_dict = JSON.loads, JSON_data, print, Python dict, hash output, name, Alice, age, 30, city, New York. Similarly, to convert a Python dictionary back into a JSON string, you would use the function JSON_string = JSON.dumps, Python_dict, print, JSON string, hash output, name, Alice, age, 30, city, New York. With these tools, handling JSON data in Python becomes straightforward and efficient, allowing you to focus on building robust applications. In the realm of data storage and exchange, CSV, short for comma-separated values, stands as a testament to simplicity and practicality. CSV files store tabular data in a plain text format, with each line representing a row and commas delimiting individual values within a row. Imagine a spreadsheet stripped down to its bare essentials, rows and columns of data, devoid of formatting or complex formulas. This simplicity is both its strength and its limitation. CSV files find applications in various domains, from storing contact lists and financial data, to exporting data from databases and importing it into other applications. Their universality, ease of use, and efficiency make them a valuable tool for data storage, exchange, and analysis across a wide range of applications. Section 5. Python and CSV reading, writing, and analyzing tabular data. Python, renowned for its data crunching prowess, offers a robust library for working with CSV files, the module. This module provides a set of functions to read, write, and manipulate CSV data, making it an indispensable tool for anyone dealing with tabular data in Python. To read data from a CSV file, the function acts as a gateway. By passing the file object to this function, you create a reader object that iterates over each row in the CSV file, treating each row as a list of strings. Each string in the list represents a cell value from the corresponding column in the CSV file. Whether you're importing data for analysis, exporting results, or simply manipulating tabular data, Python's module equips you with the tools to handle CSV files effectively. Section 6. APIs. Windows to a world of information. In the interconnected digital landscape, APIs, short for Application Programming Interfaces, act as bridges, enabling different software systems to communicate and share data seamlessly. Imagine APIs as waiters in a restaurant, taking your order, request, relaying it to the kitchen, another software system, and bringing back your food, data. This exchange of information, often in the form of JSON or XML, allows developers to access and leverage data and functionalities from other applications, enriching their own applications with external services and information. APIs come in various flavors, from public APIs open to anyone to private APIs restricted to authorized users. Understanding how to interact with APIs opens up a world of possibilities for developers, allowing them to tap into vast repositories of data and functionalities, build feature-rich applications, and automate tasks by integrating with external services. Section 7. Fetching data with Python's requests library. Python, renowned for its readability and ease of use, offers a powerful library called that simplifies the process of interacting with web APIs. This library acts as a digital messenger, allowing you to send HTTP requests to web servers and effortlessly handle the responses. To fetch data from an API, you start by importing the library and using the function. This function takes the API endpoint URL as an argument and sends a GET request to the specified URL, which is essentially like asking the server for information. Python import requests hash API endpoint URL =, https://api.example.com/data, The object returned by the function contains a wealth of information, including the status code indicating whether the request was successful, the headers containing metadata about the response, and the actual data returned by the API. Section 8. Navigating nested data, unpacking complex structures. As you delve deeper into the world of APIs and real-world data, you'll often encounter nested data structures. These structures can seem daunting at first, but with the right approach, they become manageable and even intuitive. Imagine a JSON object representing a user profile, where the user's address is not just a string, but another JSON object containing fields for street, city, and zip code. This is a common scenario in many applications, from social media platforms to e-commerce sites. This nesting of data within data, while reflecting the complexity of real-world information, requires careful navigation. Each layer of nesting adds a new dimension to the data, making it richer but also more complex to handle. Fortunately, Python's handling of JSON objects as dictionaries and arrays makes traversing these nested structures intuitive. Python provides powerful tools and libraries that simplify the process of working with nested data. You can access nested values by chaining key lookups or index access, much like navigating through directories in a file system. This method allows you to drill down into the data, extracting the specific pieces of information you need. Let's look at an example. Consider the following JSON data structure. User, name, Bob, address, street, 123 Main Street, city, Anytown, zip, 12,345 inches. To access nested values, you can use the following Python code. User_name =, data, user, name, street _address =, data, user, address, street, print, username, hash output, Bob print, street address, hash output, 123 Main Street. Understanding how to navigate nested data structures is crucial for extracting meaningful information from complex JSON objects. This skill is essential for developers and data scientists alike. By treating each nested object or array as a new starting point, you can systematically traverse the entire data structure, accessing and processing the information you need. This ability to handle nested data empowers you to work with a wider range of APIs and datasets, unlocking insights hidden within complex data structures. Mastering this technique will significantly enhance your data manipulation and analysis capabilities. Section 9. Data transformation, serialization, and format conversion. In the dynamic world of data handling, the ability to transform data between different formats is crucial. This skill ensures that data can be efficiently stored, transmitted, and utilized across various platforms and applications. Serialization, the process of converting Python objects into a byte stream suitable for storage or transmission, and deserialization, its inverse, play vital roles in this data transformation process. These processes enable seamless data exchange between different systems. Imagine sending a complex Python dictionary over a network. You can't simply send the raw data structure. It needs to be converted into a format that can be easily transmitted. Instead, you need to serialize it into a format like JSON, which can be easily transmitted and reconstructed on the receiving end. JSON is a lightweight data interchange format that's easy for humans to read and write, and easy for machines to parse and generate. Python's module, with its and functions respectively, provides a straightforward way to serialize Python objects into JSON strings and deserialize JSON strings back into Python objects. This makes data handling more efficient and less error-prone. Python import, JSON hash Python dictionary data =, name, Carol, age, 25. Beyond JSON, Python offers libraries for working with other data formats, such as CSV, XML, and even databases. These libraries provide the tools needed to handle a wide variety of data formats, making Python a versatile choice for data transformation tasks. The ability to convert data between these formats is essential for tasks like data migration, integration with different systems, and preparing data for analysis or visualization. This flexibility ensures that data can be used effectively, regardless of its original format. Section 10. Real-world applications and conclusion, the data-driven future. The ability to work with JSON, CSV, and APIs in Python unlocks a world of real-world applications. Imagine building a web application that fetches real-time stock data from a financial API, processes it, and displays it in an interactive chart. Or perhaps you need to automate a process that involves extracting data from a CSV file, cleaning it, and uploading it to a database. In the realm of data science and analysis, Python's data handling capabilities are indispensable. As we generate an ever-increasing amount of data, the ability to handle, process, and extract insights from this data becomes increasingly valuable.